absorbing at the same wavelength. Okay, so that's what this microspectrophotometer is doing. This is what it looks like. So you can identify different dyes in the fibers. Sometimes you can identify different materials. And as if you're using, if you have your samples, let's say a concentration, it's a solution, you can identify what's in that solution using this microspectrophotometer. Because again, solutions will absorb light, certain amounts of light at certain frequencies. You can tell what is in there based on what it absorbs and what it does not absorb. Usually this thing, this UV, that's ultraviolet and visible light, is a class characteristic, meaning you can tell what the thing is. It doesn't tell you where, it doesn't tell you exactly what it is. It tells you, a class of materials that it is, or a class of dyes that it is. However, IR, the infrared, meaning if you go back to this this thing here, if you're hitting it with infrared light and you're seeing what is absorbed in infrared, that is specific to a single molecule or material, mainly molecule. The ultraviolet and visible, that's usually only tells you what class of material it is. The infrared, this will tell you exactly what it is. So that's just so it depends on what your spectrophotometer is measuring. This looks like it's measuring the ultraviolet or visible, but if it was measuring an infrared, the infrared uses, let's say the light here is infrared, then it'll tell you exactly what that molecule is. You can also use not just the light that gets absorbed, but also light that gets reflected. We're not going to be dealing with that. So that is the that is the microspectrophotometer. The microscope, that also is a spectrophotometer that can find materials based on what gets absorbed and what does not get absorbed. There is also the scanning electron microscope. It's really a microscope. It's not a spectrophotometer in any way, at least not at this stage of the game. But the thing is, it uses a beam of electrons, not light, and because of that, you can magnify it a tremendous amount more. You can get 100,000 times, several 100,000 times. You can that of magnification. That is something an ordinary light microscope simply cannot do. So if you can get really, really into whatever you're looking at. Sometimes in forensics it's necessary. I mean, if you're in biology, you want to look at organelles. It's very important, but even for forensics, it's sometimes necessary to get these magnifications. Let's say tiny microscopic, really, really small things that you can use to prove that they're the same material or they came from the same source. Also, sometimes when we look at pollen, in order to identify the kind of pollen, you need to magnify this amount so you can tell exactly what kind of pollen it is. So this person might have been in a field full of buttercups, and you'll only know this, or you'll only be able to prove it by seeing the pollen on his clothing, which is buttercup pollen. But how do you know it's buttercup pollen and it's not, clover pollen? You can tell when you magnify this amount. Similarly, spores from mushrooms, you magnify that amount, you'll know exactly what it is. And so sometimes you need a scanning electron microscope. There's another interesting benefit from a scanning electron microscope. It's using an electron beam, as we mentioned, and X-rays can be emitted when this beam of electrons hits a sample. And these X-rays are unique for each element. So you can tell the element of the sample that you have. It doesn't analyze the molecule, just the element. But again, that's sometimes good enough. Like gunpowder, or guns, or bullets. Often there's lead in there. Now, we don't handle lead. People who handle lead pipes do, but we don't have lead pipes anymore. They aren't really safe. But anyway, so why would a person, let's say, when you get a sample from a skin, suspect's skin, why would there be lead on his skin? If you put this thing through this scanning electron microscope, and the X-rays that are emitted are X-rays that are unique to lead, why would he have lead on his skin? Unless he handled a bullet, or when the bullet got shot, and the gunpowder and the gun smoke might have evaporated a little bit of the lead and landed on his hands, whatever it might be. You can analyze elements using the scanning electron microscope. There are better ways of analyzing elements, but this is one way, and we can use the scanning electron microscope, also to find specific elements. And as mentioned, we have spores and pollen that are, again, they can show where a person was. These are the pollen. Pollen is they're microscopic parts of plants that it spreads from the male part of a plant, or a male, actually they do have male plants, the male part of a plant to the flower of a female part of the plant, and it'll enable the plant to give off a fruit and a seed so that it can reproduce. So it's very important for plants to have pollen. So pollen is really, really tiny. It's like dust. Very often you can't even see it. So it floats through the air, and of course people walk through fields, they're going to pick it up on their clothing without even knowing. So this pollen, if we have a suspect's clothing and we see pollen there, we can actually find out where he was for many different reasons. Like he claims he was indoors all day, and we noticed that he's got pollen from heather on his shirt, and we're going to start asking, hey, wait a minute, if you were indoors, where did this come from? So we can catch him in a lie. Or let's say we have a known criminal, and he says that he worked alone, and we can actually see from the pollen on his clothing, that he was, let's say, in this specific field. He was in a clover field and not in a heather field. So we'd look for local clover fields to see if the rest of his gang might be hidden there. Or, again, many possibilities that you can do. And the information comes from the pollen on his clothing, or maybe even in his hair. You need a microscope to catch this. This stuff is generally certainly not easily visible by the eye, and you need a microscope to examine it. Sometimes you even need a scanning electron microscope with the electrons. You need to magnify it 100,000 times in order to be sure about the pollen that you found on his clothing. It's true also for spores. Spores, they come from fungi. Mushrooms give off spores. And again, if we see these spores on him, well, maybe he was in a place where there were a lot of mushrooms, or a lot of rotting logs. Maybe he was in the woods. So we can find out, did he lie about his alibi? Maybe we know where he was. That's where he dumped the dead body. Or maybe that's where his gang was. So we need a microscope to get this information, to see what kind of spores or pollen are on his clothing. And from there, we get a lot more information about the crime. The person who analyzed this is called a pollenologist, just for your own information. So we've learned a lot about the microscope and how it's used. A little review. They know about the magnification, numerical aperture, field of view, the resolution and depth of focus, resolution from the numerical aperture, for example. Various kinds of microscopes. Also the microspectrophotometer, why it works. The scanning electron microscope, 100,000 times. Sometimes you need that. And sometimes the pollen and spores give off good and useful evidence. For those who are interested in, those who have the book and are interested in doing some problems to help solidify your understanding of the use of microscope in forensics, these are problems that you can look at.